welcome to the Red Mars podcast. I'm your host, Astro Jake, and today we're going to talk about some of the projects got coming down the line. We're going to chat a little bit about cFS, which is also known as the Core Flight System that comes from NASA, and we're going to talk about how you can implement this at home on, say, a Raspberry Pi or something like that. So let's dive into it. I wanted to start with my website here, so I've made some updates. I know I shared this with you previously, but I wanted to go a bit more in detail on kind of what's coming down the line, and then some of the projects and how we can kind of work alongside for those that are trying to get involved in STEM, specifically in the electronics or computer science areas, and how this might help you get that foot in the door or kind of get your foot wet, so to speak. So on my website here, we have Red Mars Labs. This is the newest division I've created of Red Mars to help those looking to either upscale their skill sets or upskill their skill sets. So somebody that's maybe already a professional but not quite in this field or in a different field altogether, and they're looking to kind of get their hands on some hardware such as like a Raspberry Pi. Make sure you can see that there. And something along those lines, or maybe one of the kits that I'm working on, which are these Internet of Things style ESP32 development kits that give you the building blocks needed in order to get started. So I mentioned previously that if you come to my website, I have my GitHub repositories here. Again, not a whole lot here at the moment. I'm still working locally on my machine till I get this ready to deliver it, and kind of working through my schedule. I've been really busy lately. But anyways, moving forward. So we have these builder kits that I am working on, and the one I just showed you, that's this guy here. This is the Internet of Things ESP32 Tinker kit. And this is just an example circuit here. This is a really basic one, just a few LEDs and a buzzer. And then this runs an application that from your cell phone you can go and turn on and turn off different LEDs or sound the buzzer, just showing the basic functionality of what you can do with one of these boards. Obviously, you can expand this out to some pretty complex projects, and they are very useful development boards anyways. So giving you the raw materials in order to get started. And again, I highly encourage you to use AI to your benefit to learn a lot of these things. Now, don't ask it, go write me this program, and away you go. You try and run it. And you can end up down quite the rabbit hole there of trying to fix code that you don't understand. Then you just say, okay, ChatGPT, this code didn't work. Can you fix it? And then you give it an error, and it's like, okay, make this change, and go back and forth. And that kind of exchange can go down for quite some time just because AI, it's there, but for some of these complex systems or very board-specific systems, there's different chips that supply the same ESP32 technology, and depending on how they're manufactured and built and wired on the schematics, it has a little bit functionality difference. So ChatGPT isn't always the best route. So I think that you can use it to your advantage in the sense where you write some code, pass it to ChatGPT, and ask, how could I do this better? Or my code isn't working that you have written yourself. Can you help me debug this code? Stuff like that works great and helps you really understand. And then make sure once you have a solution, ask the AI agent, whichever one you're working with, to provide an explanation for the solution that it may have provided to your problem. And that'll help you better understand what's going on. And you can get down pretty deep to pretty much whatever level you are comfortable with. And then beyond that, of course, to help you learn. So that's the IoT ESP32 Tinker Kit, more or less in a nutshell. And these will be available on my Etsy store. And yeah, I guess that's the next part of this. These will be available on Etsy through my website, so I will link directly to these products, and then you can purchase those from Etsy. And yeah, I will ship those out to you directly. Now, they don't come soldered, but if you would like them soldered, I will add that functionality, or that, I guess not functionality, that capability to have them soldered sent to you for maybe a couple dollars or something like that extra, just for my time and supplies to solder those leads on, and then go from there. But you get a lot of cool components with this, and I'll be doing different reviews of peripherals that I get as well. And I guess the first, however many of those that I have, I'll probably give away a few of them to whoever buys these kits. So the first couple kits that you purchase, you'll have some goodies in there, kind of extra to what comes in the kit usually. And then we have the wireless IR communications kit. This is going to be paired with a Pi Pico, and this is more focused on those that are interested in, say, robotics, not necessarily the wireless aspect, but it's called out as wireless because we're using infrared communications. This is just to get your hands-on experience with what infrared is, because it is a very common wavelength of sensor used for imaging in space, and then from there you can move to laser and other different capabilities, peripherals that you can pair with it. And the Pi Pico is a very capable system, so very excited about that one as well. I don't have an example on my desk here to show you right now, but I have plenty of them ready to go for those that want to purchase those kits when they are ready. And then finally, I have this back-end server starter kit, and this is going to be kind of fun, and it kind of ties into my background a bit prior to coming into the space industry. And this is focused on those that are wanting to get involved with just computer science in general. Maybe they don't have the interest in the robotics side of it, or maybe not so much on the electronics side, or they do, but they want a good starting point just into the computer science side and writing some basic code. Maybe they don't want to do Python. The previous two kits are based on MicroPython. Maybe they're looking to do C++ development and work in more of an operating system manner. So the first two kits, those are MCUs, microcontroller units, and they do not have an operating system interface similar to what I'm using here, like Windows or Mac or Linux, if you're familiar with that. The backend server starter kit is going to be a fun little desktop size. Think of like the size of your hand or smaller. Looks like a rack, a server rack, that you have boards that you can insert into there that are based on, more than likely, and I haven't solidified which chipset I'm going to use yet, but more than likely it's probably going to be like a Raspberry Pi 2040 or something along those lines, that allows you to run a Linux OS so that you can develop in, say, Java, C++. You can do Python if you'd prefer, but allows you to choose from several different languages, and you'll be able to host applications on there and serve data as you would a backend server. I have a lot of experience writing back-end applications, both in the banking industry when I worked for JP Morgan. I worked back-end edge client or edge computing clients for another company, Optimizely, where I wrote back-end APIs, pretty much code to support other developers and integrating our products into their back-end servers as well, into their products. So I did a lot of work in that area, and I've worked back-end servers also in the space industry to serve simulation data, telemetry data, and stuff like that as well. So very involved on that back end, and I thought that this would be a fun project to share with everyone as well. So these are all kits that are coming down the line, and this is just the start. I do want to provide fun little exercises, maybe even in math or propulsion problems and stuff like that, that can really get all those really that want to get involved in the space industry, kind of that first step or that first nudge to find out maybe if they even like it or not. Maybe they've been interested in space, but they never really looked at what it takes to solve some sort of propulsion problem or orbital mechanics or something along those lines, or looking at, what kind of orbits exist just in general. So I want to provide information like that to people that are looking to get started, and that's more or less our goal on the Red Mars Labs side. And so that's what we got coming down the line. Now, for some of these podcasts that are coming up, I wanted to look at these Raspberry Pis, and I've shown you a couple here. I got this one as well, and these two that I have on in my hands right now have NVMe hats on them, so that's why they look a little bit different. This is flash storage that's extremely fast too. I think these ones are 512 or a terabyte of data, and one of them specifically is going to be used as part of a test bed that I'm using to test out a lot of these peripherals in using a piece of software that I mentioned from NASA. It's called cFS. So I have these little 1U CubeSat. They're anodized aluminum frames that I designed. And if anybody was actually interested in these, definitely let me know. I have the files for them and can make more and have them sent to you if you're interested. They're a little bit more expensive because they are actually anodized and of aluminum. And technically, you could build these out and actually send them to space if you wanted to. But, if you're interested, leave a comment below. Send me a message, anything like that. I have them. They're a little more expensive, but relatively cheap in terms of CubeSats. To give you an idea, a frame like that might cost typically... the CNC aluminum one might run you $1,000 plus. These run a few $100s, so they're not that bad, and they give you a nice platform to build on. So I'll be integrating into that a Raspberry Pi along with many different sensors, and we'll be documenting that as I go and pretty much building a vehicle test bed for a 1U CubeSat, and I will have you folks follow along as I go down that journey, and I can show you how that works. Which brings me to the next topic, cFS. That is the core flight system. So this is a system that actually runs on spacecraft today, has run on it in the past, and is a very well-maintained and documented piece of software used for running real-time flight operations, and that's the communication between flight computers, flight software, and the peripherals or the sensors that are pretty much making up that spacecraft. And so this is the main site. You can go to www.coreflightsystem.net. This is, again, it's from NASA, and this is kind of your main landing page. The Get Started will bring you to the GitHub for it, which we have over here, which we'll kind of go into a bit more. I have it on a specific page that I want to talk about. But this walks through what it is. So I'll just read this for those listeners that maybe are not watching. So this is the Core Flight System, CFS, that's Charlie Foxtrot Sierra, is a reusable mission-independent flight software package that consists of an operating system abstraction layer, OSAL, a platform support package, PSP, the Core Flight Executive, CFE, CFS libraries, and CFS applications. The Core Flight System, CFS, provides a portable and extendable framework augmented with user applications to implement flight software solutions. The framework defines a layered architecture that provides a hardware and operating system independent application runtime environment. That is key. So this is what allows us to run this app or this type of software on something as small as this, a Raspberry Pi, and actually perform quite well in real time for what we need. Now, I do have an external real-time clock that'll help me track real-time events and whatnot so that everything operates at the same time so I can have repeatable tests on my test bed. And we can go into that a bit more when we talk about the actual implementation of this in other videos as I lead up to the build-out of my vehicle test bed for a 1U Raspberry Pi. And I actually have another frame coming along that has just some mild updates to it, and it'll be gold and black so we can differ between the two and talk about what those differences are and why I made those changes. All right. So this is more or less the stack of what makes this CFS. So we have user applications, Core Flight Executive API, with the CFE implementation itself. We have the OS Abstraction API and OS Abstractions. This is what allows us to run on top of the Linux environment or whichever OS we are running for our, our test bed or our implementation of hardware. We have platform support package APIs and PSPs, as we previously mentioned. So we have our framework and then the platform abstraction layer, and then user applications sit on top. Now, what makes this great is the way that data is shared between the underlying hardware or computing system that runs this software, and then the different peripherals and hardware systems that sit on top of it that really make your spacecraft able to live and breathe and function in the space environment, and all the different sensors that make that happen. And so this uses a publish and subscription style of architecture over a shared memory space, or what they call a software bus. And this allows different applications to serve or publish that data that it needs or subscribe to response data that it is requesting. And then the different sensors will then communicate back and forth, also publishing or subscribing to those same data elements. And that's how they share information back and forth. And that is why I wanted to go to this next one where it talks about what the software bus interface is. So, the software bus is an inter-application message-based communication system. The main objective of the software bus is to provide a mechanism that allows systems to send packets without regard of where the packet is routed and receive packets without the knowledge of where that packet came from. The software bus uses a message-based subscription approach for establishing these communication paths. Any application may send a software bus message. The software bus will route the software bus message to all applications that have subscribed to receive the software bus message. In order to receive a software bus message, an application must first create a pipe on which to receive the software bus message. So think of it as you have this big hose running down a line with all kinds of information in it. If you want a little bit of the water that's going down that hose, you're going to tap into that and stab in your own little, stab might be a little bit violent. You'll poke in your own little hose that siphons off a little bit of that water. That is the information that you care about. Then maybe you'll put a little bit of backwash back in there. A little gross, I know, but it's my analogy for the day. Bear with me. Anyways, the reason I wanted to bring this up is this is really like the core functionality that makes this architecture work really well. Now, there's a lot more to it than that, so I'm not going to say that this is just it. But I definitely encourage you to go through, read through all of this document here, and then click on the Get Started, take a look at this, and really dive into what this core flight system bundle consists of and how you can use it. And then I encourage you to get involved. Now, the CFS software will not run on my little development kits, which is fine. CFS is definitely a lot more involved, and if you're just getting started out, or you're just starting out in this space, I would not say this is the place for you to begin. But the sensors I will be using and how they communicate will work with the development kits that we have here, and I will also do different episodes on how those communicate. Specifically, there's things like I2C or I2C, depending on what you're familiar with, how people say it. I2C is one communication, there's SPI, there's UART, and all these, if they sound foreign, that's not a problem. We will talk about them and go into detail in different episodes on what these actually are and how you can really learn them. They're not honestly that difficult once you understand how they work and the fundamentals of how data is exchanged and what these things break down to. And these little development kits are the perfect way to really learn that. It gives you just what you need to have those building blocks to build that foundation. So if you're going to a job interview or something like that, you'll be able to nail that job interview because you have been practicing on your Red Mars Labs development kit. And that goes for either one, the wireless one that I mentioned here, which, with the Raspberry Pi, with the Pi Pico, and then the IoT ESP32. Either one of these will be perfect examples for learning how to use any of those different types of what we call protocols for communications, or just generic serial data. And so we'll talk about that. And then for the backend server one, this is focused more on the computer sciencey side of things. So things like Java, C++, and whatnot, and serial communications over RJ45, so your Ethernet adapter over USB and whatnot. That'll be more so the use case there, not so much the GPIOs. GPIOs are these little guys that look like pins coming off a board. The easiest way just to reference them is those little pins go into your microcontroller unit. You can see them here as well. I got a bunch of little wires, jumper wires coming from that over to what we call a breadboard, which is your development board that allows you to quickly prototype different types of circuits and test them out before you go and say build a circuit or something like that. Now, once we get into actually building circuits, you can come and learn along with me as well as we dive into an application called KiCad and look at how we lay out a circuit, build the schematic, and then actually route it for a PCB design. And I am learning as I go on that one. I do not have as much experience laying out the boards themselves, and it is quite interesting to say the least. So we'll get into all that in other episodes. There's a lot of content coming down the line that I hope you guys are excited for and interested in and whatnot. But again, we'll be giving away a lot of these different peripherals with these kits as they become available. I'm hoping within the week to have the first kits posted on Etsy. And then, so look for that for my next podcast that I release, where we can talk about, what are some of the peripherals we're we playing with, and then I'll have, one or two extra, and the first couple kits that go out will get one of those peripherals thrown in, along with some other goodies that I can find. I got lots of different parts sitting around here that might be good starting points for those that are interested. So when you buy your kit, definitely let me know what your interests are and what you're looking to do, and if I can, provide something in the kit to give that to you, I will. I'm here just to help other people learn. And, this helps me kind of stay current as well as learn in this field as well. Never stop learning. That's the biggest thing, stay curious, keep looking up. That's why I say it, I got to keep looking to what's next. The moment you stop learning and you become complacent in something, it's over. You're not going to progress any farther in career or anything like that. You become kind of stagnant, and that's not good. So I'm always trying to find new things. So that's why I'm looking at PCB layouts right now and building those types of more complex boards, because I'd like to build my own Red Mars Labs development boards, not just, the kits, but I want to do peripherals. So like my own sensors, sometimes I get peripherals and I was like, it'd be really nice if it had this functionality. And the one I have doesn't have that. So I can build out more a developer-friendly schematic and then get those boards made and sell them as well on my Etsy store for other people to take advantage of. And again, I'm not looking to make any kind of real money on these. These are more so just to, cover the cost of what it takes me to put these together and then sell them to whoever wants them. So it takes some time to build these out. And so that's pretty much all it is. Like a kit like this, I'm looking at maybe $30. It cost me almost that to put this together and then send them off. So more or less breaking even for the most part. Anyways, they will be fun. They'll give you what you need, and they will get you kind of that next step towards whatever your goals really are. Let me know what they are down below. If I can help cater to any of your goals or get you one step closer, I will do what I can to get you there. But yeah, so lots of fun stuff coming down the line. Definitely looking forward to doing some episodes on the 1U CubeSats and building these out, and really seeing how far we can get through, different episodes. I'm going to keep building on this. So first we'll start with the Raspberry Pi. We'll get cFS installed on that. We'll see how that looks. We'll play around a little bit, and then we'll start integrating our first payload or peripheral to that application and see what integration really looks like and get us there. And it'll be a lot of fun to see what you think and get your feedback as well. So with that, I hope you enjoyed this episode. I hope I didn't ramble on too long for all of you, but more good things coming down the line. Oh, one last thing. I actually picked up, I don't know if you can see it behind me here. Move my seat out of the way. There we go. I got a new 3D printer that I wanted to try out. It's one of the Bamboo Labs A1 Mini. And I really wanted to see what a good beginner 3D printer is like these days. I've been 3D printing for many, many years, and I have one actually printing right now. Some parts for it just to make my setup a little bit easier for me due to the space that I have. But I've been using this one called Kitty Tech and other 3D printers, and I've used a lot of Anycubic ones, from the Chiron to the older, I don't even remember what they used to call them, but similar to the Prusa, they had one that came out. And anyways, that's the moral story. I got this new 3D printer. It's a very small one that fits in small spaces, so if you're just looking to get started with some of this stuff and you want to build little 3D printed parts and stuff like that as well, I want to be able to give you an honest review of what this one's like and use it for building out different mounting mechanisms and stuff like that for this 1U CubeSat. So I can give some honest feedback on that as well if you're looking to get into the 3D printing space also. It is very great for rapid manufacturing, as you can see with my 3D printing right now. And we can go through what some of the CAD looks like for that as well. I use Autodesk Fusion 360. It works very well for me. There are other versions out there. Whatever works for you and you are comfortable with really will do the job. So, yeah, we'll talk about that in the next episode as well as we get building. So with that, as always, stay curious, keep looking up, follow along, subscribe, turn on notifications, and I will see you all in the next episode. Thank you, everybody.